When people think of design, they don't necessarily think about things on the molecular level. Things like manipulating DNA to create complex machines that perform tasks at the nanoscale, or engineering bacteria and viruses to create products or perform tasks, that's really exciting stuff.
For 30 years, we've been creating software to help people create and design all the things around us. We're taking some of that software and some of that knowledge around design and creation and manufacturing and bringing it into new domains of biology and nanotechnology.
You can see in all levels of biology, whether it's in the population level all the way to the molecular level, that there is a very tight interconnect between form and function. What we're working on is a 3D web-based viewer that specializes in visualizing large-scale molecular data, and that allows us to provide a way to look into this kind of unknown territory that you wouldn't normally see. Because at the nanoscale, you're looking at 1/billionth of a meter. The viewer is really a foundation or a platform for us to be able to build design tools on top of it.
So DNA nanotechnology is about creating DNA constructs that will do useful things. In particular, DNA origami is a technique where we create shapes by using a long strand of DNA and making it fold with these tiny staples.
DNA origami constructs can be used for a wide array of applications. You have medical applications, and inside the DNA origami clamshell, you can put some very, very, very toxic chemicals that kill cancer specifically.
We collaborated with the VC Institute to create CAD Nano 2. That is a CAD tool for DNA origami. Since then, we've been making more advances on DNA origami in general. We've actually created a project to fold the Autodesk A, our logo.
Biology is empirical, and so the design principles up until now have been very difficult to get a hold of. And because we're getting the hang of the blueprints now, and we're able to make the blueprints now because we can synthesize and read DNA so accurately, we can apply engineering principles to them. So when you apply engineering principles to biology, you get synthetic biology.
Through synthetic biology, we can make microbes do things that they won't do naturally. Things like producing insulin, things like producing biofuels.
Our work in bioprinting is we're not developing printers as much as we're working with primarily the Ember printer and developing bioresins for the Ember printer. But the applications for that would be things like producing a scaffold out of a hydrogel. Hydrogels are the substances that cells like to adhere to. And if you produce a trabecular lattice, you could grow cells on those trabecular lattices, potentially cartilage or bone.
The whole idea of using the power that Autodesk has in software engineering and funneling it into these research domains is really powerful and awesome.
The goal of the Autodesk BioNano research group is to try to move the needle on design and manufacture in these promising and really explosive areas. We want to knock down the barriers that are preventing exploration and really affect the world in a positive way.